Hi, here we have two circles with centers P and Q cut each other at two distinct points A and B. Okay, so you have sort of two circles, they cut each other at two distinct points A and B. Okay, the circles have the same radii. Okay, the radius is same. The center of the circle is P and the center of the circle is Q. Neither P nor Q falls within the intersection of the circles. Okay, so this is the intersection of the circles. So P and Q will not lie in this region. Fine. What is the smallest range that includes all possible values of angle AQP? Okay, so we have to figure out angle AQP. This angle. So what is the range or smallest range for this angle? Okay. So range is basically when the least possible value of this angle and the highest possible value of this angle. Now the highest and the least possible value of these angles will be when you have two extreme cases. Extreme cases as in when these circles barely touch each other, although it's given that these circles touch each other at two distinct points. But what you do is, see, you have two circles. Now if you pull these circles apart, the intersection area will keep reducing and there will come a point where their intersection, the two intersection points are almost same. So let's consider this case where the two circles touch each other. Now this is P, this is Q, and both the points A and B are the same points here, right? So in this case, the angle AQP, now APQ are all on the same line. So angle AQP is 0 degrees, right? So the angle AQP, obviously this is not the case. These two points have to be distinct. That means the centers will not be so much apart, they will be slightly closer. Hence this angle AQP will not be 0, it will be slightly more than 0, right? So the angle should definitely be greater than 0. Angle AQP should definitely be greater than 0. This is one extreme case. The other extreme case is when the two circles pass through the center of each other. Although it's given that the circles are not in the intersection region of the circles, but since if we start bringing these centers closer, the closest they can come is this case, right? So here you'll have A, here you'll have B, this is P, this is Q. This will not be the case, but this would be the extreme case. Obviously the distance between P and Q have to be more than this because P and Q cannot lie in the intersection region, but this is one extreme case. So now the angle AQP, what about this angle here? Let's see. Now we know the radius of the two circles is same. So if this is center, this is nothing but radius of this circle R. Similarly QA is the radius of this circle, which is also R. And PQ is nothing but radius of both the circles, which is also R. So if you look at triangle AQP is an equilateral triangle because all the three sides are equal. Hence all the three angles will be 60 degrees. So the angle AQP can be maximum 60 degree. Now if you start pulling P and Q apart from each other, this angle will start reducing. So the angle AQP should definitely be less than 60 degrees. So the angle must be greater than 0 but less than 60. Hence the best range that we have here is option C. Okay, thank you.